In this video I'll look at a Kenwood VR606. It's a 5-channel, 100 watt per channel, yeah right, home theater system. This thing's a few years old and it looks like it's seen better days. It looks like it's been sitting in, in a garage or something for the last 10 years. Well, maybe not 10 years, but a few years. Nicely scratched up, but yeah, we'll see if we can get this one going. It's completely dead. There's nothing. Put power to it. Oh, I've got power to it now. As you can see, it's totally dead. So we have to look into the standby supply to see, because we're not getting any clicks or anything from the relay. We have to look at the standby supply to see where the problem might be on this one. Of course, the first order of business is to check and see if the fuse is blown. So we'll get the meter out here. And we'll just check the AC fuse and see that the fuse is not blown. So now we need to find the standby, and that's the main fuse, but there's actually another little circuit board underneath here, which is the standby board, and that'll have a separate transformer on it to power the remote control circuits. That little transformer is going to be down here, and since we have no attempt to turn on the power, that is where I have to start. I have to start on the standby supply. So to get at that, I'm just going to remove a couple screws on the back side here that hold in this little circuit board and the convenience outlets, and that'll allow me access to the board below it, which is where the standby transformer is going to live. So it just makes it easy just to swing this whole board out of the way. Now I have access to the standby supply. We'll turn it on, we'll plug it in, we'll power it up and see whether we have any standby voltages. And even though I am plugged in now, I do have the power turned off on this thing. So I'm just going to swing this out of the way so it doesn't touch anything, and we'll check for our standby voltages off of the transformer down here. This little part down here, this is our bridge rectifier. So that rectifies the AC side, is the back side. This is the DC. You can see it marked positive and negative. That's the rectifier for the standby. So if I turn on the power and I measure this with my meter, I should have a voltage. I do indeed have 11.93 volts DC. So that tells me that the standby is working, but the unit's not turning on. So we have to look to the next step, or next stage. If I check my standby voltages leaving the power supply here, you'll see I've got two standby voltages here. I have a 7.2 volt standby voltage, and I have an 8 volt standby voltage. Don't know what they're supposed to be, but I'm assuming that those are probably correct, and they go over to this connector on the front of the board. So I've got those two voltages coming up on the front of the board, but the other lines have nothing. Again, I don't know whether they're supposed to have any voltage on them or not at this point. My standby light is not illuminated on the front of the panel here, though. There's a little red light that's supposed to be lighting up to indicate that we have standby, and we don't. But we've got voltage coming off of the regulator in here. There's an 8 volt regulator, and we do have voltage on the regulator. Therefore, I think our standby voltage is making it over to the front microcontroller board. So I have to take a look at that and see whether there's something on the front board that's causing a problem on here, because obviously with no standby voltage, nothing's going to turn on. Here's something interesting I just noticed when I just moved this thing. I heard relays click. Here, look at that. We have a problem on this board here. We have a problem on this board. You hear the relay clicking? We have a problem on this front board here. I'm going to pull the board out. We'll take a look and see what's going on with this. But definitely, now I hear the relay clicking. Oh, now I got my standby light. My standby light's working now. It's on. I can hear the power relay click. I hear the speaker relay click. I have no display here. Oh, now I do. My fluorescent display just lit up. See that? We have a connection problem on this board. You can hear it. You hear the relay clicking. I just by sheer luck, I did my voltage measurements here, and I just happened to press on the board, and I heard a relay click. So that gave me the clue that the problem's on here. So now I'll just get this board out and we'll take a look at it. But this is where the problem is going to be. It's going to be on this board, and it's going to be a broken connection. So I've got the board out now. Just going to remove some of these covers here to kind of shield it so I can see all these connections underneath here. And then I'm going to go through this thing with my high power magnifying glass and take a look. Take a look at the connections along here and on some of the flat pack ICs here. Look for any connections that aren't looking good, and we'll resolder ones that look suspect. This IC861 here, this is going to be the display controller for the fluorescent display, and this is going to be our main CPU. Our power comes in over here, and this is our interface. So I'm going to get in here a little closer and take a look and see. Get a little closer and take a look and see for, first of all, inspecting it with a microscope, which in my case is just a TV camera lens, so I can get in real close and actually look at them and visually inspect everything, and we'll take it from there. Well, for starters, it looks like that one is bad, right in the middle of the board here. That one there looks to be, yeah, that one's bad right there. That's one. That's the first one I've spotted. I'm just going to look a little more here. I'm just going to get the iron warmed up, and we'll do that one first, and then I'll just do any other ones that look suspect. And I'll show you the ones I find, but for sure that one, for starters. The cheap Chinese soldering iron is, get the tip on this thing, it's a joke. Hasn't lasted me very long. My old one lasted me forever. This thing here, I've only had this thing a couple months, and already the tip is just about shot. I'm going to have to go and get a new one. I haven't had this thing very long. I haven't used it that many times. Okay, so I'm going to resolder a couple of these connections. There's a few of them along here that I see that are in need of attention. So we'll just do a few of them here that I can find, and then we'll test this thing out again. So that one for sure is bad. And I'm going to redo the entire display. This is the display connectors here. These ones along this row here. These are the fluorescent display. I'm going to resolder the entire fluorescent display, because several of them are cracked looking. And there's more over on this side. This one here is bad. It was really bad, that one. Hopefully my camera's in focus. I'm on manual focus now. It's just so I can, I don't like autofocus, they tend to hunt, so I'm looking at my monitor here, it looks to be pretty sharp. Okay, those ones all look good now. I think what we'll do is we'll just try it and see if it still cuts out. Of course I can do that just by, I don't have to put it back together or anything, I can just power it up here. Power it up. Power standby light is on. Power on, we have a display. Oh, we still have a problem, you see. It still kicks it out when I... Okay, we still have a problem. At least I got the display. The display is working. So now I have to look for some more on here. Either another bad connection or a crack or something. So let me look with the magnifying glass again. I'm going to flux and reflow the main micro. A couple of the connections on this side look a little bit suspect under the microscope. So we'll just get our solder flux out here and just put some more around the connections on this side. This will help the solder reflow. There's these ones here. Look like they could be buggered up. These ones. Do the edge connectors here because a few of these looked suspect, not broken as bad as the obvious one over there by the display, but a few of them looked a little flaky, so I'm just redoing those ones. There's another one over here, this ground over here looks a bit off. That one there doesn't connect to anything, but we'll solder it down anyway. I'm also going to do these edge connectors here that interconnect with these other ribbon connectors. And of course there's the power connectors that bring power to the board in the first place. These ones down here. Oops. That light is starting to act up on me again. I may have to replace these with LEDs if it keeps up. Okay, let's see if it works. Of course, the answer to that is no. We still have a problem. So let's look for more cracks. That one right there. That one right there, I think that's probably our problem. See that connection right there? You can see it cracked. I think that's probably going to be the one that's causing this problem. Let's do something about it. There could be others, but this one I've certainly spotted this one, so let's do something about this one right here. And see whether that is the only one. I'm going to look for others as well, but that one was bloody obvious that that one was bad. So we'll test it now and see whether the fault is resolved. No, it's not resolved. I still have no power, but if I squeeze the board, my standby light comes on, and then it'll turn on. Let's see. So we still have a problem. So we'll look a little closer. Here's another one. Right there where my fingernail is. You can see another cracked connection, so let's just redo that one. Right there. Okay, let's see if it works. Okay, power on. Haha, got it. That was the one. Now the standby light works. Before, as I say, when I was touching the circuit board, I would just flex the board. It would cut in and out, and that's got it. That one connection that I just showed you, that was the one. And I'll show you where that connection was and how I went about finding it. Okay, it was, where was it? It was right in the middle of the board here somewhere. It was right there. I think that was the one. Yeah, that was the one there. So this was it here. And if we follow the trace back, I'll zoom in the camera a little bit here so you can see it kind of in some focus. So this was the connection that was causing the problem. It was that one right there. We follow the trace back. It comes back through here, works its way along, and it comes back to one of the standby pins over here. Of course, one of the problems with using a real high-end camera like this that I'm shooting this on, and I'm shooting this on my Sony 4K, only because my kid's grabbed my other camera and he's playing around with it for some of his projects, so he wanted to borrow a camera. I loaned him my other one. The only downside to this, of course, camera is it's got a big sensor, so it's got a relatively narrow depth of field. So it becomes a challenge to keep the whole board in focus. What's in focus over here is out of focus over here. Anyway, the connection that was bad, if we follow the trace through, the trace comes back through here, and then around through here, and I know it's off through the side here, works its way through here, around through here, and you can't see what I'm showing you. But it starts, so what I did is I knew that I have an 8 volt and a 7 volt supply over here, and I traced this one, and everything looked good on that one. So I went and I followed this next trace, and the trace comes up and it went around through here and ended up over here, and it ended up in this area here on the board. And I started looking and spotted that connection that was cracked. Did that one connection. Prior to doing that, the amp was still cutting out when I flexed the board. After resoldering that one, it solved the problem. Let's get this thing back together and see if it works. So, I've got the circuit board shield here. I don't even know why this thing's here. I guess it's to prevent the ribbon cables from getting damaged from the sharp edges on the board itself. Anyway, it snaps on like that. There's a couple screws in the bottom to hold it together. I'm sure glad that the problem on this unit ended up being on the front board, because this is one of those piss poor designs where they neglected to put a hatch on the base of the unit for doing any work on the main board. It makes working on equipment like this very difficult, because you basically have to pull the back off it, and you got to pull everything out and lift the board out, including the heatsink, to do any work on the main board. This unit here does use these IPMs though, STK 413-220 and an STK 412-220 are the two IPMs, which stand for Integrated Power Module. So basically the entire amplifier is in one module. Got a couple of regulators on here, but and everything else is buried. All your switching and everything's buried on these boards here. Signal processing. It's a low-end amplifier. It's mine. It was given to me, and now that it's fixed, I gotta find it a home. I'm sure I'll have no trouble getting rid of this thing for a few dollars. But let's hook it up to some speakers and see how it sounds. Okay, hooked up the speakers. Power it up here. Turn it on. See, the volume is turned down. Holy smoke, that's a big mosquito. Where did that thing come from? Well, it's not gonna bite anybody now. Dead. Done. Done like dinner. Okay, input select. I'm on tuner. Let's see if we can tune something in here. Listen mode. And I don't have an antenna on it, so works. I've got a little inside the house. I have a little modulator that I broadcast my satellite dish music, and if I just hook a little piece of wire up to this thing, gotta find an alligator clip here. I should be able to hook that up to the antenna terminal, and it should pick up the signal. This thing's not very strong, so I'm just looking for one of my small little clips here that I can clip on. I got these big redonkulous ones, but I don't think that's going to clip very well into, maybe this piece of wire will work. Yeah, that'll work. It's fixed. As you can see before, when I just touched the board, it would cut in and out. So there we go. I have this nice scratched up Kenwood that I'll have a hard time even getting 20 bucks for this thing because it's all beat up, but what the heck. It was a garbage can find. It's fixed. I hope you enjoyed this video. We'll catch you in the next one. Bye.